Hello folks, I'll go over in this video I'll go over the derivatives of natural exponential functions. With the natural exponential function we mean f of x equals e to the x with the base number e approximately 2.72. The first fact that we know, it's really simple, but if you take the derivative of natural exponential function you'll get itself, e to the x. So in other words, if you take the derivative of, or if you differentiate e to the x, you will get e to the x. So that means this is a special function for any multiple of this function, 5e to the x, 10e to the x. All those functions have the same derivative by themselves. Like an example, just we can consider, for example, take the derivative of 3 times e to the x. This is going to be itself 3 times e to the x. If you take the derivative of, for example, let's say 6e to the x, that's going to be 6e to the x itself. So if you multiply by a constant, it will have the same derivative. Now, a little bit harder example, if you take f of x equals x squared multiplied by e to the x. Now you see, if you know the derivatives of polynomials, yeah, we know the power rule. But for this case, we have a polynomial function x squared, quadratic function, multiplied by e to the x. So it's a product, and you cannot take the derivative directly, but you need to use the product rule. So you have the first function, you have the second function. Because that we have a product in here, there are two different functions, one exponential, the other one polynomial. So remember, if you take, like, say f for the first one and s for the second one, the product rule says if you take the derivative of the product, you take the derivative of first one times it by the second plus first one times the derivative of the second. So we're going to be using this rule. So if you take f prime of x, the derivative of first one is 2x, and then times it by e to the x, and then plus the first function, which is x squared, and the derivative of e to the x is itself. So you see both terms in here contains an e to the x, which you may just factor out if you want to simplify this derivative. So it's going to be 2x plus x squared multiplied by e to the x. So this is how you find the derivative when you have a product. And let's go to the next page, next example. Now consider this one. When you take the derivative of something like e to the x divided by x to the third. So as you can see, now the previous one was a product, this one is a quotient. And for the quotient rule, if you want to take the derivative of something of the form like top and the bottom, just to make it more simple, if you take the derivative of a quotient fraction, it's going to be the derivative of the top times the bottom minus top times derivative of the bottom divided by bottom squared. So in our example, the derivative of f will be the derivative of top, just e to the x itself, times the bottom, which is x to the third, minus the top is e to the x, and times it by the derivative of the bottom, which is 3x squared, and then divide the whole expression by x to the third squared. So so this will, you can again simplify, you can factor out e to the x. So you have e to the x, then we have x to the third minus 3x squared, and divided by x to the 6. This is how we simplify. Now another fact, another rule that we have in here, that's just we can just say this is the other fact, is that it's just coming through the chain rule that if you take the derivative of a function which is combined by e to the x, see e to the f of x. By chain rule, first you take the derivative of the outer function, which is e, and e has derivative itself, so you will keep f of x in e, so it's going to be e to the f of x, and multiply it by the derivative of the inner function, which is f prime of x. Here, we just use the chain rule. So, like a basic example, consider this one. You're taking the derivative of, let's say, e to the 8x. So that's going to be itself first, e to the 8x, and multiply it by the derivative of the exponent, which is 8. So just keep that in your mind. This 8 is the derivative of the exponent. So if you simplify, that's going to be 8 times e to the 8x. So you see, you're simply just using the chain rule, but you have to first keep e function itself and then multiply it by the derivative of the exponent. So let me just go over another example about this. For example, look at this one. This example, it's y equals e to the power negative x squared plus 4x and then minus 7. So if you look at y prime, that's going to be, you keep it e to the negative x squared plus 4x minus 7, and then you times this by the derivative of the exponent by the power rule. That's going to be negative 2x plus 4. See, it's really straightforward. So you can simplify. We usually write the polynomials in the front, and it's going to be negative 2x plus 4 multiplied by e to the negative x squared plus 4x minus 7. Like this is just one which you have a quadratic simply inserted in the exponential. Now look at this one. Let's insert a radical function into an exponential, like take y equals e to the power squared of x squared minus 3. So you see, the main point is this: if you want to take the derivative of a radical function, you need to write it with the rational exponents. You can clearly do that. Like square root, for example, it's just, that means power to the power 1 over 2. So the first thing that we apply here is just to rewrite this function. It's going to be e to the power x squared minus 3 to the power 1 over 2. And when you take the derivative now, I'm going to write a little bit detailed. So it's going to be function itself, e to the power x squared minus 3 to the 1/2. Now you times it by the derivative of the exponent. Now, why do I write this separately now? Because you will need to use the chain rule again in here, like for the exponent, because you have a polynomial inserted into a square root function. So that's going to be, you keep that e to the power x squared minus 3 to the 1 over 2. Now take the derivative of exponent, which is going to be 1 over 2 x squared minus 3 raised to the power negative 1/2. Because don't forget, 1 over 2 minus 1 is negative 1/2. And then you times this by the derivative of that inner function, which is simply 2x. See, this is like, I can write here, it's the double chain rule. So that's the double chain rule. And you see, you can simplify this, like 2 here, 1 over 2 and 2, they will cancel, and negative exponent means you can write it at the denominator. So this is going to be e to the power square root of x squared minus 3 times, we have x divided by square root of x squared minus 3. This is how you simplify that further. So let's just go over one application problem. one application problem. Um, Look at this. Let's say example. Let's say you deposited $50,000 into an account, and let's say it's compounded continuously. So, which means you're going to be using the formula A equals P e to the RT, and then the rate, let's say, is given to be 1.25%. So the question is this: with this information, can you find A of 5, and can you find A prime of 5, and interpret their meanings? So what they mean. Interpret the meanings of them. What do they mean? Like in terms of the problem, what we mean by A of 5 and A prime of 5. So if you look at the solution, the first thing that you need to do is you have to write down your function. Here time is the variable, just changing my time. Rate is fixed and the initial deposit amount is fixed. So you have to write A of t as 50,000 initial value, e to the power, the rate should be in decimals. So it's going to be 0.0125 multiplied by t. So this is what you have in your account after t many years. T is in years. So if it says like first A of 5, you simply plug in 5 in here. So it's going to be 50,000 e to the power 0.0125 multiplied by 5. And you can use the calculator, the basic one. You will use the exponentiation rule tool in there. And if you look at this, it's the answer that you will get is 53,224 and 72 cents. So this one is a basic level. You just plugged in 5. So that means you get the value in your account after 5 years. So this is the value of the account. Folks, sometimes you say future value, sometimes it's just the value after 5 years. After 5 years. So the next, you need the derivative now. And the derivative is just we use the chain rule. So A prime of t, keep that 50,000 in there. E to the power 0.0125 times t, and then times this with the derivative of the top. Derivative of t is 1. So it's going to be 0.0125. It's like, for example, you take the derivative of 2x, it's going to be 2. 5x is going to be 5, because derivative of t to the 1, x to the 1, these are all 1. So you can simplify that to 625, because don't forget, you can combine this 50,000 by this constant, 0.0125. So 625 e to the power 0.0125 times t. So this is the derivative function. Now we will plug in 5 for this. So I find A prime of 5, which is 625 e to the power 0.0125 multiplied by 5. And you will get this to be 665 and 31 cents. And this is like per year, because you're finding the rate of change of this account at that time, 5 years. So if you want to write the meaning, what that really means, this is going to be at that time. At that time, which means like t is just simply 5 years. At 5 years, the value of this account is increasing at a rate of 665 and 31 cents per year. So it gives you the rate of change. And this is the rate at which that account is increasing. So thanks for watching. And I hope that's helpful. Bye.